What's up guys, and welcome to this video. We are going over the 2017 IEB AP Maths exam. This is the calculus and algebra exam, and this question on question 7 is on mostly differentiation and using Newton-Raphson's method or Newton's method. So let's get straight into the question. So question 7. Okay, so it says, if y equals minus 1 over the square root of 4x plus 3, then dy dx equals m over 4x plus 3 to the power of n. And they want us to write down the value of m and n respectively. So basically they want us to calculate the derivative and then give the values of m and n. Okay, so let's start off with what y is. So y equals, this can be written in a better format for our differentiation, which we can say, okay, let's just write the original as it was, plus 3. So that can be written as y is equal to minus 4x plus 3 to the power of minus a half. Okay, those two, the left hand side and the right hand side, are equal. Okay, now we can differentiate that much easier now using our simple chain rule. So dy dx is going to be multiply the exponent down, so that's going to be minus a negative times a negative half, which is a half, and then what stays in the bracket stays the same, 4x plus 3, and then the power drops by 1, so that's going to be minus 3 over 2, and then we have to differentiate the inside. So the derivative of 4x is just 4. Okay, so if we multiply that through, we get that's equal to 4 times a half is equal to 2, and that's 4x plus 3 to the minus 3 over 2. So now we can write it in the format that we want, which is dy over dx is equal to 2 divided by 4x plus 3 to the power of 3 over 2. Okay, and this is equal to m over 4x plus 3 to the power of n. So therefore we can equate these and we can say that m is equal to 2 and n would therefore be equal to 3 over 2. Okay, nice and simple, and we get ourselves 5 marks. Okay, so that was question 7.1. Okay, question 7.2 says sine of y plus cos of x is equal to 1, and y is between 0 and pi over 2. Then it says find dy dx. Okay, so this is actually, we've got variables of x and y, so basically we can't just differentiate normally, we actually need to do implicit differentiation. Okay, and I've covered that in a previous video. So if we want to differentiate this, we are going to say that the derivative of sine y is equal to cos y, so we're differentiating in terms of x, so that's the important thing. We are differentiating in terms of x, so wherever we differentiate y, we have to add a dy dx. So sine y, the derivative of sine is cos, so it's going to be cos y, but we need to add a dy over dx, plus cos x, the derivative of cos is minus sine x, is equal to, and the derivative of a constant, which is 1, is equal to 0. Okay, so now we can get our expression dy dx is equal to sine x over cos y. Okay, and we get 5 marks for that, which is quite generous. I guess it's because you had to do implicit differentiation. Okay, then it says calculate without a calculator the gradient of the given curve when x equals pi over 3. So basically that was part A, and for part B we are given that x is equal to pi over 3. Okay, and we want to calculate the gradient. So what we're going to do is, therefore we can say that this equation, the original equation, sine y plus cos x equal 1, we can now substitute x equals pi over 3, and that equation then becomes sine of y plus a half is equal to 1. So what we can say is we know that sine y is equal to 1 minus a half, which is therefore a half. Therefore we can solve for y. Y is now equal to pi over 6. Okay, so now we have a value for x and we have a value for y. So we actually have coordinates. Okay, so we have the coordinates pi over 3 and pi over 6. Before we only had the x coordinate, now we have both. Okay, now we can use the equation we derived over here. Let's call that equation 1. Now we just substitute the coordinates into equation 1. So we can say dy over dx is equal to sine of x, which is pi over 3, divided by cos of y, which is pi over 6, and that is equal to 1. So dy dx, or the gradient at that point, is equal to 1. Okay, and that's that answer, and we get ourselves 5 marks. Okay, so the important thing to realize here is that we also should have, the reason why this is pi over 6 is because we needed y to be between the range of 0 and pi over 2, as was given in the question. Yeah, so the important thing to realize in this question was that we had been given the x coordinate and we needed to calculate the y coordinate in order to get our gradient. Okay, so question 7.3, let's do it next to this question. So question 7.3 says, Rajesh wants to find a solution to the equation tan x plus x squared plus 1 equals 0 using Newton's method. If he uses x equals minus 1 as an initial value, calculate Rajesh's fourth iteration as it would appear on his calculator to 4 decimal places. Okay, so let's start off with that. So 7.3, okay, so the important thing is we need to use Newton's method, or Newton-Raphson's method, okay? So what is Newton-Raphson's method? Basically, the equation for Newton-Raphson is x to the n plus 1 is equal to x to the n minus f of x to the n over f dash of x to the power of n. Sorry, xn. So basically what we need is this xn is going to be our guess value, or the initial value, right? F of x is our actual function, and then f dash of x is our gradient. Okay, so we know what f of x is, so we can say that f of x is equal to that equation, which was tan x plus x squared. So tan x plus x squared plus 1. Okay, so from this we can get f dash of x, which is the derivative. The derivative of tan is sec squared, okay, and sec squared is 1 over cos squared of x, plus the derivative of x squared is 2x, and the derivative of 1 is 0. So now we've also been given what our first guess is, or our guess value is. Okay, so x naught, we can say, is equal to minus 1, as it was given in the question. So basically the important thing here in this question is to know how to use your calculator. Okay, so Newton's method can be done directly on your calculator without having to do much work and just clicking equals over and over again. Okay, so the way that we do this is when we plug into our calculator, we say that the answer is equal to our first guess, which is minus 1. Okay, and then what we do is we replace x with answer everywhere in the equation. Okay, so basically what we can say is x to the n plus 1 is equal to, so this is what it should appear in your calculator. So it would say answer minus, so we've got the function, so tan of your answer plus your answer squared plus 1 all over 1 over cos squared of your answer plus 2 times your answer. Okay, so we already know what our initial guess was, so we can say that x naught is equal to minus 1. Okay, and then what you do is you click equals, and that gives you your first iteration, and they want the answer to 4 decimal places. Is it 4 decimal places? Correct. Yep, 4 decimal places. So the answer is minus 1,3105 would be our first iteration. Okay, then what you do is you click answer again on your calculator. So the second iteration is minus 1,2273. Click answer again. X3 is equal to minus 1,1818, and X4 is equal to minus 1,1724. Okay, and this would be this would give you that answer. Okay, so that would be your answer. For the fourth iteration, that is your answer, and you get yourselves 7 marks, which is very generous. Okay, and then it says continue the iteration to calculate the answer to 7 decimal places. Okay, so what you do then is you keep clicking answer, and you make sure basically after each point your decimal value should stop changing. So then you click answer as many times as you need to get the 7th decimal place to not change. And in this case, so this was part A, in this case for this question, after 7 iterations, so after clicking equals 7 times, x to the 7 is correct to 7 decimal places, which is minus 1,1720936. Okay, so it's not always going to happen that your 7th decimal place is accurate. On the 7th iteration, you might need to go more, you might need to go less, but in this case, it just worked out to be on your 7th iteration. Okay, so yeah, that's that question done, and that's 24 marks. Yeah, so not too difficult. I hope you guys found this video useful, and thanks for watching.